of the new Valve hardware. So ignoring the SteamDeck that came out a couple of years ago, the Steam controller, Steam machine, and Steam frame, only one has yet to release, that being the Steam frame. Now, I don't particularly care about VR. It's just not really my thing. I've done VR a couple of times. I think it's neat. It's just not something I really care about. However, I do care about the Steam frame because it is an ARM-powered device. It is an ARM-powered device running Linux. Linux gaming on an ARM-powered device. Now, that might not sound like that big of a deal, but before a couple of years ago, we weren't doing this. Nowadays, we have projects like Box 64 and, of course, the Fex project. Fex, which is being sponsored by Valve. This has completely changed the space on what can actually be done with ARM. There are projects like Game Native and Game Hub on Android. These are a way to play your Steam games on your Android phone. Now, it might not run super great because you're still gaming on your phone, but if you're playing some of the lighter titles, you can just play your Steam games on your phone. Not doing streaming, right? Like, not streaming it from your PC. No. Actually playing your Steam games on your phone. And of course, not just things in Steam. There's no reason why this tech only has to be used with Steam. You can play your Epic games. You can play any other game you might have on Windows on your phone. That's really cool. And right now, we're kind of just at the beginning of things. We're at a year, 2 years into the project being a thing, and only very recently that people are really starting to learn that the project exists. This is kind of like the early days of Proton, where things did work, but it wasn't clear exactly how well it worked and how many games did work, and a lot of things just hadn't been tested yet. This is a space which is going to evolve incredibly quickly. But there's also the matter of the distro itself. So you probably know that SteamOS is based on Arch Linux. This creates a little bit of a problem because Arch Linux does not support ARM. Now, there is the Arch Linux ARM project, often just called Alarm. This is not technically Arch Linux. It is a separate branch. It is a separate project. It's also not exactly that well maintained. Basing off of mainline Arch is totally fine. There is a lot of work being done here. Basing off of Alarm, you kinda might as well just do everything yourself. Now, there have been some efforts to officially support ARM in mainline Arch Linux. There is this porting effort. It's not really gone anywhere just yet. This page is basically the extent of what you have. There's a little bit of work being done, but it is so far from actually being something you'd want to build something like a SteamOS around. However, that doesn't mean there is no plan forward. And recently, Collabora put out this blog post, building an Arch Linux AArch64 port for Holo Core. AArch64 is 64-bit Arch Linux, and what is this Holo Core thing? So, you might know about a project known as Holo ISO. This was a way to run SteamOS on just generic hardware before we had the recovery image available, before we had any sort of understanding of how to easily go about doing this. Holo is the internal name used for SteamOS, so Holo Core is another thing that is around this Holo ecosystem, and Holo Core is what is going to be running on the Steam frame. Valve used an adapted version of the Arch Linux distribution in its products. At Collabora, we have been working with Valve on Holo Core, a pure AArch64 port of Arch Linux to be used as the basis for the OS running on the Steam frame, which used an AArch64 CPU. Since Arch Linux does not officially support the AArch64 architecture, we have needed to work on the tooling and the CI infrastructure to make this possible. This is another one of the many organizations that Valve has been working with in actually getting things done in the Linux space. They very well could have just gone and done their own thing, done things internally. Instead, what they have done is said, okay, we're going to fund Collabora. We're going to fund these people at KDE. We're going to fund these people doing FEX work. We're going to fund this. We're going to fund that. And actually benefit everyone. The way Valve is acting in the FOSS space, in the open source space, in the Linux space, this is the way that I think a lot of people want companies to behave here. Now, Valve's not perfect. There are problems. They are the reason we have all of the skin problems in video games. But you win some, you lose some. In this first step toward opening up the work on the AArch64 port, we are publishing prepared binaries, their sources, and the development containers we've built from them, allowing anyone to begin to explore the port and experiment with Arch Linux on AArch64. I have seen a lot of people calling this project basically the alarm killer. And considering that Valve is going to have to keep maintaining Arch Linux on ARM for the Steam frame for as long as they want to support the device, I can kind of see why. Do note, though, that with this being the basis for SteamOS, it's not going to move at the same speed as something like an Arch Linux does, so your mileage may vary there, but with all of the work being open source, with all the tooling being open sourced, you could relatively easily use this as a basis to go and expand off and do something different. At this stage, we have not rebuilt the entire world, all the packages available in the Arch Linux repositories. Our initial goal is to provide the set of packages required for development and image creation for the Steam frame, but it sounds like the goal is at some point to do everything. Again, alarm killer. Even when limiting ourselves to this subset of Arch Linux packages, including these packages along with their runtime and build dependency, still results in several thousand packages. The idea behind this port is much more complex than simply recompiling and installing selected packages for the AArch64 architecture. We are trying to solve two main problems. Build binaries from recent Arch package versions for a foreign architecture, so build it for something that is not x86-64, and create a CI system, a continuous integration system, capable of building binaries for a distribution that currently has no CI infrastructure of its own. As Arch Linux is a rolling release distribution, enable this CI system to determine the correct dependencies to use as the distribution updates. And this isn't just a matter of, grab the latest things and just build it and everything just works. Because of course it's not. It is more or less known how to create a port, initial cross-compilation, bootstrap preparation, package rebuild, and so on. However, it becomes much less obvious when you want the entire process to be reproducible from scratch in CI. We also have to calculate the correct build order for the dependency tree. Here we encounter the first caveat. We cannot rely entirely on the state of the Git repo, which tracks the history of Arch Linux package repositories. In many cases, batches of packages are pushed into the repo in an order that is not suitable for rebuilding, meaning that we have to correct the ordering ourselves to construct a valid build sequence. Arch Linux has tooling around how to handle their build order, but if you want to do all of this yourself, now you've got to work out how they're actually doing it. Another major challenge comes from the nature of Arch Linux's rolling release model. While we are preparing the initial port, the packages and their dependency chains keep moving forward, often several steps ahead of the state we had been working on. Arch Linux isn't just going to stop doing what they're doing. If you want to build off something slower like an Ubuntu or a Debian, that problem doesn't exist, but Arch Linux, it's a constantly moving target. During the development process, we have already stepped forward to newer snapshots a few times. However, we cannot simply skip intermediate versions because of package interdependencies. Intermediate package versions are often required to build later versions, which in turn are needed for other package versions. For example, if you need to rebuild Rust 1.91, you must first have 1.90 available, which itself requires 1.89, and so on, all the way back to the version used during bootstrapping. And I know what you're gonna say. I'm watching you. Rust bad. This is not a Rust problem. This has nothing to do with Rust. Rust is just an example being used here. It's a popular example, it's a known example, but it is just an example being used. Once you have all of this in place, you don't have a problem going forward. The issue is you've got to get things in place and you've got to have that build pipeline that can continuously integrate, that continuously get you up to the latest version. A similar issue arises with name transitions. This is shared object names. It's basically just a way to identify these shared objects. Something like a libc.so.6, that is one of these shared objects, especially for libraries that are part of the build infrastructure itself, such as ICU or GPG-ME, both of which are required by Pacman. In this instance, the package manager used to perform the build dependencies on the old library version, while the package manager being produced by the build must depend on the new one. Thus, both must be available when the build is performed. So, trying to update the package manager to new dependency versions requires both of those versions simultaneously being available and not conflicting with each other. Time is the biggest enemy when trying to replay a historical build sequence. If you try to catch up with Arch Linux by rebuilding packages from months or years ago, you will inevitably discover that the upstream landscape has changed. Sources may have moved, projects may have migrated to different hosting services, checksums of Git sources may change because short commit hashes that were used when the package was created have since been expanded to a longer form, and countless other issues can arise. Thankfully, as a user, these are things you don't really have to deal with. Yes, there are sometimes transitional issues when there are like GPG key expiries, things like that. But by having a distro, by having these people who are dealing with all of these complicated problems, it makes actually using Linux considerably easier as the user. There was a time where you had to deal with all of this stuff yourself. Now, back then, a lot of things moved a little bit slower, and you probably also had a lot less installed, but even so, I'm so happy distros exist. You may also face infrastructure problems that did not exist when those package versions were first released. Nowadays, many upstream services actively defend themselves against aggressive bots and AI crawlers by limiting download rates, restricting connections, or temporarily blocking clients. This can be painful for CI pipelines that rely on downloading sources directly from upstream. That's not even mentioning packages that are simply not compatible with the AArch64 architecture and require additional patches to build and run correctly. And of course, there are always corner cases and human mistakes to deal with when maintaining your own Arch Linux port. And this is not even every single problem they've had to deal with, just most of the notable ones. In order to replay the Arch Linux build history, we had to develop a complex set of tooling to deal with the issues above. Working on the tooling was entirely iterative, bouncing back and forth between bootstraps, build trees, and deadlock resolutions, and fixing the tooling to be able to solve those issues and progress past them. The tooling can calculate the complete build tree, resolve the full dependency chain, and then replay Arch Linux package builds from an initial bootstrap up to a specific snapshot of the state of the Git repository, including all necessary intermediate rebuilds. The GitLab-based CI is able to build all of these packages in a repeatable manner. The tooling is not yet ready to be published, however, our team is working on it. So what they are doing here isn't just saying, oh, we have an ARM version of Arch Linux. This is taking the entire history of Arch Linux and then being able to stop at any point along that history and say, I want the ARM version at this point right here. Whilst the infrastructure developed to this point is capable of building from first principles up until a point-in-time snapshot, the next step is to build this into a system which can track Arch Linux as it is developed, because it's all well and good to be able to do this historically, but you want to do this into the future as well, so you can actually build something that continuously updates based off of this system. This work will serve as the basis of a continuously operating CI system capable of shadowing Arch Linux itself. We will work with the upstream Arch Linux project to help Arch with the efforts to port the distribution to AArch64 architecture and work towards automated, repeatable builds. Again, do you understand why people are saying, this is the death of Alarm, this is the death of Arch Linux ARM, this is going in the direction of the mainline project having full ARM64 support? If you want to build the preview yourself, there are instructions here. It's literally just Arch Linux on ARM, so it's not exactly that exciting to look at, but you can go and do so if you really feel like doing it. So what is next? We are continuing to work on the tooling with the primary aim to be able to efficiently keep the AArch64 port up to date with the package revisions that are being used to develop future versions of AMD 64/x86-64 flavor of SteamOS. We are proud of what we've achieved so far and help to provide access to the tooling in the near future. We have aspirations to open this up far more and work on a common approach with those interested in bringing both CI infrastructure and an AArch64 port to upstream Arch Linux distribution, providing some benefit back to the community, which provides the foundations on which SteamOS is built. This, I think, is super, super cool. And again, this is part of what I love about how Valve is approaching Linux. They could have just said, we're going to do this internally, we're going to keep it all proprietary, nobody has to see it. Instead, they go to Collabora and say, yo, build this thing. And don't just build it for us. If you want to just, like, let everyone have it and have it just be, like, a upstreamed thing in Arch Linux, which they're probably discussing, like, Valve's probably discussing that with Arch Linux as well, because I know they've been working directly with them as well. Like, that's just cool. It is just cool that somebody is actually doing this. The goal here wasn't just to build an ARM version of Arch Linux. Alarm does exist, albeit poorly maintained. And it wasn't just, oh, let's have a distro that is working on ARM because you have Fedora Linux and various other things out there. But SteamOS is based on Arch Linux. And the goal here is to be able to take Arch Linux, take the entire history of Arch Linux, and then build an ARM version at any point in that history, and then get the tooling out there and empower people to just have Arch Linux ARM be as good as it can possibly be. Besides my phone, I don't have an ARM64 device, but doing this also opens up that possibility as well. Yes, there are plenty of distros for running on a phone. I'm not going to say no to more of them, and I'm not going to say no to a mainline Arch Linux that could potentially go down that route, let alone all of the other devices that are out there. Like, there are some ARM laptops out there. They're not super common. Mostly they're in the Chromebook space. But, hey, that opens up some more stuff with that as well. Now, the Intel Chromebooks are the ones you really want to get, but the ARM stuff is also super cool as well. Whilst I'm probably not going to buy a Steam frame myself, I do hope that at least something here does well. I know people like the Steam controller, but the Steam machine, there was a lot of drama around that one, so hopefully the Steam frame pricing is not as bad. But the Steam frame also has RAM in it, and it has storage in it, so we'll see how that goes. I know Valve's been talking about how RAM is only going to get worse before it gets better, so we'll see. At the very least, at least the software side of things is really cool. I like the work they're doing on Waydroid. I like the work they've done with Fex. I like the fact they're making an ARM64 version of Arch Linux, and all of this is just open. You can just go and use it. And all that's cool. So, let me know your thoughts down below. If you liked the video, go like the video. Go subscribe as well. Go press the hype button on mobile. And if you really like the video and you want to become one of these amazing people over here, check out the Patreon subscribes to Liberapay, linked in the description down below. That's going to be it for me, and show me your arms. Money that I don't accept.